कर्व होता है, अगर उसका एरिया हमारे पास फाइनाइट आ जाए तो फिर उस हिसाब से हम डिटरमिन करते हैं कि बॉटम का भी एरिया फाइनाइट होगा। मतलब अगर टॉप कर्व कन्वर्ज कर रहा है तो बॉटम कर्व भी कन्वर्ज करेगा, और अगर हमारे पास बॉटम कर्व का इनफाइनाइट आ जाए एरिया तो हम कहते हैं कि फिर एफ ऑफ एक्स का भी इंटीग्रल इनफाइनाइट ही आएगा।
Yes, good, very good. So how to determine, if we are given a question that determine whether this integral is convergent or divergent by using comparison theorem, then how will you proceed? Other than Ali Raza and Vanya and Fatma Sohail, how will you?
क्वेश्चन क्या था, एक बार रिपीट कर दें।
The question is that you are given an improper integral and you are asked to determine the convergence of the given integral by using comparison theorem. क्वेश्चन आपको ये है कि एक इम्प्रॉपर इंटीग्रल दे दिया गया है, आपसे कहा गया है कि कंपैरिजन थ्योरम को यूज करते हुए डिटरमिन द कन्वर्जेंस ऑफ द गिवन इम्प्रॉपर इंटीग्रल, देन हाउ विल यू प्रोसीड? तो कैसे आप करेंगे, क्वेश्चन को कैसे सॉल्व करेंगे?
मैम पहले स्टार्ट करेंगे तो उसका कोई मतलब उसके अबव वाला जो है फंक्शन बनाने से, जो से ऊपर, और फिर उस अगर ऊपर वाला फंक्शन जो से ऊपर आ रहा है अगर वो कन्वर्ज हो रहा है तो नीचे वाला भी लाजमी कन्वर्ज होगा। अगर तो उसमें 4 केसेस बनते हैं, उसमें से कोई केसेस वगैरह देके हम सॉल्व करेंगे।
ठीक है, the first two cases, for the first two cases we can draw conclusion, for the case 3 and case 4 we cannot draw conclusion. ठीक है, तो हम ये cases discuss कर लिए थे. So basically what we do, we are given an improper integral, we construct or build a function to compare with the given function and then find the integral of the function which we have constructed. उसको इंटीग्रेट करेंगे, या तो उसको इंटीग्रेट करके उसको बताएं कि वो कन्वर्जेंट है या डाइवर्जेंट है, या आपके पास जो रिजल्ट है देन यूज दैट रिजल्ट. फॉर एग्जांपल 1/xp, इंटीग्रल ऑफ 1/xp फ्रॉम 1 to infinity. तो फिर आप इसको चेक करके देखें कि ये इंटीग्रल कन्वर्ज करता है या डाइवर्ज करता है. इसकी बेसिस के ऊपर आपने गिवन इंटीग्रल को कन्वर्जेंस या डाइवर्जेंस ड्रॉ करनी है. तो इसके लिए आपने ये याद करनी है कि अगर आपने एक बिगर फंक्शन कंस्ट्रक्ट किया है तो बिगर फंक्शन को कन्वर्जेंट होना चाहिए. अगर आपने जो फंक्शन कंस्ट्रक्ट किया है जो कि टॉप फंक्शन आ रहा है वो डाइवर्जेंट है तो फिर आपका प्रोसीजर गलत हो जाएगा, आपको कोई और फंक्शन बिल्ड करना होगा. सॉरी, वो कन्वर्जेंट आ रहा है. बिगर फंक्शन अगर आपका डाइवर्जेंट आ रहा है तो बॉटम फंक्शन जो कि आपका गिवन फंक्शन है उसका इंटीग्रल के कन्वर्जेंस या डाइवर्जेंस के बारे में आप नहीं बता सकेंगे. तो इसके लिए आपको अपना फंक्शन चेंज करना होगा. इस तरीके से अगर आपने ऐसा फंक्शन बिल्ड किया है जो कि बॉटम फंक्शन आ रहा है जो कि आपके गिवन फंक्शन से लेस देन है और वो फंक्शन कन्वर्जेंट आ रहा है, तो फिर भी आप कोई कंक्लूजन ड्रॉ नहीं कर सकेंगे. जो आपका स्मॉलर फंक्शन आपने अगर आपका कंस्ट्रक्ट जो किया है फंक्शन वो स्मॉलर है, उसका इंटीग्रल कन्वर्ट कर रहा है, उसको या तो डाइवर्ट करना चाहिए, या अगर आपने एक फंक्शन बिल्ड किया है जो कि बिगर फंक्शन है उसको कन्वर्ट करना चाहिए, तो ही कंक्लूजन ड्रॉ कर सकते हैं. अदरवाइज फिर आपको अपना फंक्शन चेंज करना होगा, फिर आपको कोई और फंक्शन बिल्ड करना होगा. आपकी चॉइस ठीक नहीं है, चॉइस चेंज करनी होगी. ठीक है, सो दैट्स व्हाट वी हैव डन इन इम्प्रॉपर इंटीग्रल्स. सो वी आर गोइंग टू स्टार्ट our new section, 10th chapter, and it is about parametric equations and polar coordinates. This is our 10th chapter and we start it with 10.4 section of this chapter, Thomas Calculus, 11th edition. So today's topic is curves defined by parametric equations. So far we can describe the plane curves. How can we describe the plane curves? We can describe it in two ways, either y in terms of x or x in terms of y. This is the first description, or we can describe as an implicit function as well. So these two are the descriptions of a plane curve. Plane curve is a two-dimensional curve that lies on a plane. So these two are the descriptions of a curve. So in this section, we describe two new methods for describing curves. That is, other than these two descriptions, How can we describe a curve? The first one is parametric equations. Some curves, such as cycloid, are best handled when both x and y are given in terms of a third variable t called the parameter. Other curves, such as cardioid, have their most convenient description when we use a new coordinate system called the polar coordinate system. So we will move towards two new description of a curve. We will represent curve either by parametric equations, or further we can describe a curve in a new coordinate system which is called polar coordinate system. So first we will deal with the parametric equations. So in this section we will learn about parametric equations and generating their curves, right? So what's the problem in describing the curve in these two ways? क्या मसला आता है कि हमें एक नई डिस्क्रिप्शन की जरूरत पड़ती है कर्व को रिप्रेजेंट करने के लिए? Why do we represent curve in other coordinate system and by other equations? जी here we have represented yes
मैम अगर हम उस टर्म में उन्हें रिप्रेजेंट करते हैं तो उनके साथ भी डील करना हमारे लिए आसान हो जाता है.
yes, it could be one of the reason that we can handle it properly. So here I have y is equal to f of x, that is y is a function of x. So it means if a particle starts its motion from this point, moving along this path, and this like this, can we represent it in as a function of f of x? Can we represent as a function of x?
No मैम फंक्शन नहीं है.
Yeah, this is not a function because this does not fulfill the condition of the function, and the condition of the function is that for each input we have a unique output, and graphically it means that it must satisfy the vertical line test. We draw a vertical line at each point on x-axis, and it should meet the curve at only one point. But here we can see that it is meeting then more than one point, so this does not fulfill the condition of a function, so we cannot represent it in this way. Y is equal to f of x. So we need another representation for this curve, although it's a curve because it shows the motion of a particle moving in this way. So how to represent? We introduced a new variable which we represent as t, and call that variable as the parameter, and then represent x in terms of t and y in terms of t. Now these two equations are called parametric equations of this curve C. That is what we do since we are unable to represent this curve C as a function of y or as a function of x, or we cannot represent it in terms of y because it does not satisfy the horizontal test. This representation is also not possible. So we move towards another representation of the curve C. For this, we introduce a third variable t called parameter and express x and y as a function of t. Express as x in terms of t, x and y both in terms of t. What is the domain of t? What are the values of t? T belongs to the real numbers. It could be some close interval or open interval, or it can be all real numbers. So this representation is called parametric equations of fn of the curve C, and this curve C is called parametric curve. Parametric curve क्या होगा फिर? Parametric curve क्या होगा फिर? Parametric equations तो ये होगी.
यस मैम, वो कर्व जो इन दो वेरिएबल से डिफाइन की गई हो. सर सर्कल को हम डिफाइन कर सकते हैं कि x equals a sin theta and y equals a cos theta.
Okay. Basically, if we put different values of t, I will get different points xy. By plotting these points xy, I will get a curve. That curve is called parametric curve, right? By giving different values of t in the parametric equations, I will get different points. And by plotting all the points on the Cartesian coordinate system, I will get a curve, and that curve is called parametric curve. So these are the definitions. Basically, I've explained all the things. ST varies the point xy, which is represented by this, varies and traces out a curve C. This is called a parametric curve. Let's see an example. We are given parametric equations. We have to sketch and identify the curve defined by the parametric equations. X is equal to t square minus 2t, y is equal to t plus 1. Now the range of t or the domain of t, the values of t is the all real numbers, so we can start with any number. So let's put t is equal to 0. When would we put t is equal to 0? What are the values of x and y?
X is equal to 0, y is equal to
X
1.
equals 0, y equals 1.
So what about t is equal to 1?
X is equal to minus 1, y is equal to 2.
Y is equal to 2. What about t is equal to 2?
X is equal to 0, y is equal to 3.
What about t is equal to minus 1?
X is equal to 3, y is equal to 0.
Good. T is equal to minus 2.
X is equal to 8, y is equal to minus 1.
So I can take up to any values. It's up to you how many values you take, how many values of t you need to plot this curve. What about t is equal to 3?
X is equal to 3, y is equal to 4.
Okay. Now starting with this 8 minus 1. 8 minus 1 lies. Is it 8 minus 1? Yes, 8 minus. Let's say it's 8 minus 1. Then 3, 0. 0, 1. Minus 1, 2. 0, 3. 3, 0, and then 3, 4. So when I join these points, the smooth curve, the direction of this curve C is in the increasing direction of t. T is increasing in this direction. So this is the increasing. This point correspond to t is equal to minus 2. This point correspond to t is equal to minus 1. This is t is equal to 0. This point 1. This point correspond to t is equal to 2. And this point 3. So this curve seems to be a parabola. That is, you take different values of t and then find corresponding values of x and y and then plot these -2, -1, then up to this. Right? This is how you will sketch parametric equations or parametric curve by taking different values of t. You will find the corresponding values of x and y and then plot the point x and y. Now, we have identified this curve. This curve is a parabola, seems to be parabola. Let's confirm it by converting these parametric equations into the form y is equal to f of x. So for this, we need to eliminate t. How to eliminate t? You can use any method. So I am finding this equation implies that t is equal to y minus 1. So I will put it in the other equation, in the equation for x, y minus 1 square minus 2 y minus 1. So this become x is equal to y square minus 2y plus 1 minus 2y plus 2. So this is x is equal to y square minus 4y plus 3. So this equation is quadratic in y and linear in x. So it represents a parabola. So now we can confirm or verify it. We have verified that this represents these parametric equations represent a parabola, right? All of you have got how to draw parametric curve. Okay.
Yes.
Now let us restrict ourselves. If we have restricted t from 0 to 4, what about t is equal to 4? What are the values for t is equal to 4? It is 8. 8, 5 lies somewhere. Okay. For 0 to t lies between 0 to 4. It means you have to remove these points. The values of t from 0, here is 0, 1, 2, 3, and 4. This will be your curve, required curve. Sorry, this. T is equal to 0 to t is equal to 4. If you restrict t from 0 to 4. So this is my initial point and this is my terminal point. Initial point where the values of t start is at here. The terminal point it is here at t is equal to 4. That is, if we restrict our t from 0 to 4, then we will get this curve, the part of this curve, not the whole curve, part of the parabola. And we can determine the initial and terminal point. This is the initial point and this is the terminal point. Okay, now example 2. What curve is represented by the following parametric equation? X is equal to cos of t, y is equal to sine of t. The value of the parameter is from 0 to 2 pi.
Unit
This is a
circle.
How would you draw this circle then? If I eliminate this squaring and adding, cos square t plus sine square t is equal to 1. So this implies that x square plus y square is equal to 1. But we will draw it in parametric equations. So first taking t is equal to 0, t is equal to pi by 4, t is equal to 2 pi by 4, which is pi by 2, t is equal to 3 pi by 4. Okay, determine all of these points. What about t is equal to 0? It is 1 0. What about t is equal to pi by 4? It is 1 over under root 2. 1 over under root 2. What about pi by 2? It is
0 1
0 1. What about 3 pi by 2? 3 pi by 4? Minus 1 over
minus
under
1
root
over
2.
under
1 over under root 2.
yes
Okay. What about 4 pi by 4 over 4?
minus 1
This is
0
minus 1 0. Similarly, we will determine other values pi by 4, then 3 pi by 2. At t is equal to 3 pi by 2, basically 5 pi by 2, 6 pi by 2, pi by 4. What about 3 pi by 2? This is
0
0
minus 1
minus 1. T is equal to 10 to 5. Let's say 2 pi is equal to 1 0. Now I will draw. The first is 1 0 lies over here, then minus 2 at this point, 0 1 minus 1 0, and 0 minus 1, and then 1 0. I will stop here. So I will get a circle in anti-clockwise direction. This is t is equal to 0. This is t is equal to pi by 2. Similarly, this is t is equal to 3 pi by 2. T is equal to pi. For t is equal to 0 and t is equal to 2 pi. So I will get a circle in anti-clockwise direction. So this curve, this parametric curve has some direction which is represented, which is described by increasing direction of t. This is my curve. Is in the counterclockwise direction or anti-clockwise direction. So example 3. What curve is represented by the given parametric equation? So let's see another example. What about this curve? X is equal to sine t, y is equal to cos t. What about this curve?
Circle, but in the opposite direction.
In opposite direction, how? How do you know? For t is equal to 0, the point is
0 1.
0 1. For t is equal to pi by 2, the point is 1 0. For t is equal to pi, the point is 0 minus 1. So it could be in the opposite direction. For t is equal to 0, the point is 0 1, which lies over here. And for 1 0, then 0 minus 1, then we will get this point, and this would be the same circle, but it is in opposite direction. Okay, that is in clockwise direction. This curve, this parametric curve is in anti-clockwise direction, and this parametric curve is in clockwise direction. Both represent a unit circle. So what about this curve?
मैं ये सर्कल होगा लेकिन इसका जो रेडियस है वो आई थिंक स्मॉल हो जाएगा।
मैम ये 2 रेवोल्यूशंस घूमेगा।
रेडियस स्मॉल हो जाएगा। ये देखें जरा, इसको ऐड करें, एक्स स्क्वायर प्लस वाई स्क्वायर इज इक्वल टू साइन स्क्वायर 2t प्लस कॉस स्क्वायर 2t which is equal to 1. So it represents the same circle, same unit circle. Radius is 1 and center at origin. Okay. लेकिन ये डिफरेंट किस तरह से है उससे? जी कैसे डिफरेंट है उससे?
मैम ये क्लॉकवाइज डायरेक्शन में 2 दफ़ा इसकी रेवोल्यूशन होगी।
t इज इक्वल टू 0 पे बताएं क्या पॉइंट आ रहे हैं, जल्दी जल्दी बताते जाएं। ये है 0 1, t इज इक्वल टू पाई बाय 4, t इज इक्वल टू 2 पाई बाय 4, t is equal to 3 pi by 4, t is equal to 4 pi by 4, t is equal to 5 pi by 4. पहुंच गए pi by 2 pi तक। चलो, so what are the corresponding points? Pi by 4 it
1
is equal to 1
1 0 1 0
1 0. For 2 pi by 4 that is pi by
0 minus 1
0 minus 1. For 3 pi by 4 it's 3
minus
pi
1
by 4.
0
Minus 1 0. Good. For pi
0 1
it is equal to 0 1. For 5 pi by 4 it is equal to 5 pi by 4 it is ओके। ये सारे आप डिटरमिन कर लें और ये फिर इसके बाद 8 पाई बाय 2 के ऊपर क्या आ रही है, 2 पाई पे क्या आ रही है, 0 और 1।
0 1
देखें 0 1 इसमें 2 दफा आ रहा है, बल्कि 3 दफा आ रहा है। फिर 1 0 1 0 दोबारा आगे जाके आएगा। सो इट विल द सेम सर्कल, द कर्व इज द सेम सर्कल बट the particle will move twice. That is, this circle will start from this point, that is 0 1, as you can see. So t is equal to 0, the point is 0 1 0 1. Then moving in this direction this, तो फिर पाई के ऊपर यहाँ पे वैल्यू आ गई और दोबारा फिर ये रिपीट करेगा, वैल्यू रिपीट करते करते यू विल गेट 2 पाई पे ये दोबारा से ये कंप्लीट हो जाएगा। सो इट इज द सेम सर्कल बट इट विल मूव ट्वाइस अराउंड द सेम यूनिट सर्कल। 2 दफा रिपीटेशन हो रही है इसकी, तो इसमें आपके पास डायरेक्शन जो है वो इम्पोर्टेंट है। ठीक है जी। So now you can distinguish between a curve which is a set of points, a parametric curve where the points are traced in a particular way. Now you're supposed to solve the example 4, which is find the parametric equations for the circle with center HK. You will solve it by yourself. Now, what is this? Sketch the curve with parametric equations. This x is equal to sine t, y is equal to sine square t. Yes, x is equal to sine t. If I eliminate t, I will get y is equal to x square. So it represents a parabola. But how will I draw this parabola? I will draw this curve by using parametric equations. Different values of t, taking different values of t, I will get different values of x and y. So hurry up and tell me different values of t. Yes. For t is equal to 0, the value is the point is
0,0.
0 0
0 0. For t is equal to pi by 4, the point
One
is
1 over
1
under
over
root
under root 2 and
1
1
over
over 2. For 2 pi by 4 means for pi by 2
pi by 2 1 1
1
1
1
1. For 3 pi by 4
minus 1 over under root 2 1 over 2.
minus, it's minus 1 over under root 2.
Oh, sorry, 1 over under root 2 1 over 2.
Okay. For t is equal to pi, the value is
0 0.
0 0.
0 0
For t is equal to 5 pi by 4, the value is, the point is for 5 pi by 4, the point is
minus 1
over
over under
under
root
root
1 by 2
minus over under root 2 1 by 2. For 3 pi by 2,
2 minus 1 or
1.
1.
Okay. Now 7 pi by 4. For 7 pi by 4, the value is
minus 1 over under root 2 1 by 2
minus 1 over under root 2 1 over 2. For t is equal to 2 pi
0
0
0.
0
0 0. For t is equal to 9 pi by 4, I am taking at an interval of pi by 4. What is 9 pi by 4? It is equal to pi
1
by
over
4,
under root 2
which
1
is
over
1
under root
over
2 1
under root 2, 1 over under root 2. Okay, I can take any values so that I can draw it conveniently. So basically, if I look at these points, I can see that the values of x is between minus 1 and 1. And the value of y, the maximum value is y of is 1 and the minimum value is 0. Because x is equal to sine t and sine t, value of sine t is from minus 1 to 1 always, and when we square it we will get its value always lies between 0 to 1. So it means the value of x is between 1 and minus 1. The value of y is between 0 and 1. So how will I sketch it? 0 0, 1 over under root 2 would be over here, then 1 1 in this point. Then again it is 1 over under root 2 this point. I will move this way first. Then again it is 1 over under root 2. I will return. And then 0 0 this point, minus point this point, and then minus 1 this point. Moving in this direction. Then again I will return to this. And then 0 0. Then 1 over under root 2 this point. Then again I will get 1 1. Then this point, this point, this point. This means that this is a parabola, but the motion is to and fro. I will move this way and then back to this point and then back to this point. So since sine t is a periodic, so this particle will move to and fro in this direction, and such direction is called, is shown or represented by, this is a periodic motion represented by the pendulum. Okay, तो -1 और 1 के दरमियान ये ऑसिलेट करेगा, ऑसिलेशन है ये. कि जी आज के लिए इतना ही काफी है. So if you have any question, you can ask me. Yes, students. No question?